All right, so this example here, it says determine the exact value of cos of 135. So there's a lot in this question, and everything that we've learned in this lesson so far is wrapped up in this question, okay? So first of all, exact value, no decimals, okay? Do not just punch this into your calculator, cos 135, get a decimal, write it down. That's not an exact value. So an exact value is a fraction form, including the radicals or anything that might be in that. So exact. So we don't want to just plug this into our calculator. We also need to know what a reference angle is, and we need to refer to our special angle triangles, okay? So no calculator required here for this question. So 135 is this angle right here. Okay, there's 90 plus 45 gives you 135. What is the reference angle for 135? That's really important to know, the reference angle. And it is, so you go 180 minus 135 is? 45 is correct. Good, 45. Now, why is that important? Well, we know that the trig ratios for 45 degrees are associated with the trig ratios for 135 because 45 is a reference angle. Notice that it's called reference angle. We refer to the trig values for this angle to get the other trig values. So we refer to this angle. All right, so a special angle triangle that has 45, if you recall, you should have this memorized. A 45, 45, 90. And the values here would be 1, 1, square root 2. And we determine those using Pythagoras' theorem. That's the simplified version of the lengths of these sides of this right triangle. Okay, from that right triangle, from that special triangle, I know what cos of 45 is. I can see, here's 45. And cos is CAH, so ka toa. So it's adjacent, here's adjacent, divided by hypotenuse. And here's hypotenuse, right? And so the cos of 45 is adjacent over hypotenuse, 1 over square root of 2. Now this is an exact value. That's an exact value. Your calculator will give you a decimal. This is an exact value. So finally, we need to know, how does cos of 45 relate to cos of 135? Well, if you remember from the lesson, cos of 135, because this is a reference angle for 135, is going to be equal to exactly 1 over root 2. It's going to be the exact same number. With the one exception that possibly it may be negative, right? So here's your cast rule, meaning that all angles are positive if it's a first quadrant angle. Over here in the second quadrant, where this angle is, only the sine value is positive. So sine is positive here. An angle in the third quadrant, tan is positive, and an angle in the fourth quadrant, only cosine is positive. And here all is positive. So only the sine is positive, so the cos has to be negative. So the exact value of cos 135 is negative 1 over root 2. Now, you could check this with your calculator, which I will do. Okay. So I'm going to go, where's my button here? On. So cos of 135 equals, and you're going to want to make sure you're in degrees here, okay, for this, degrees. That's the cos of 135. That's what our calculator gives us. Again, this wouldn't be good enough for this question. But let's figure out what negative 1 divided by the square root of 2 equals. And look at that. Exact same. Exact same as far as these number of decimals are concerned. So we've got this right. Everyone see that? This is the exact value for the cos of 135. So what do we need to know? We need to know about reference angles. We need to know about our special angle triangles. We need to know about the cast rule and how all of those tie together. All right, I'm going to give you an example now to try. So for your turn, find out for me the exact value of, let's say, tan of 225. Nope. Yeah, tan of 225. Sure. Why not? Okay, so go ahead, take a moment, and try that on your own, and I'll show you the answer in a minute. All right, so tan of 225, tan of 225. So what you need to remember is we need to remember that the reference angle is the key to finding out the exact value here. And there's going to be a good chance that the reference angle will be part of those special angle triangles, okay? If it's not, we'll deal with that as it comes. But in this case, 225 has a reference angle of 45 because 180 plus 45 is 225. So I'm going to focus over here on the tan of 45, my reference angle. I'm going to refer to the ratio for the reference angle here. So if I draw my special angle triangle, and remember that for an angle of 45, tangent is opposite over adjacent. That's 1 over 1. So the tan of 45 is 1. The tan of 225 is going to be either positive or negative 1. And so I put the 1 down there, and then I checked my cast rule, C-A-S-T, and I notice that the tangent is positive when my angle terminates in this quadrant. So the tangent is positive. And so I've written positive 1. And I checked that on my calculator. Tan of 225 is indeed positive 1, just to confirm on your calculator. Okay? Question?
So when you're doing tan, which is like, what if you, because I did like 360 subtract that. And I got like
Okay, that's a good question about the reference angle. So if you have 225 as your number, you don't want to consider this as a reference angle here. So if you did 360 minus 225, right, you're going to get an angle that is not acute. So remember, we want to deal with an acute angle. Reference angles are always acute angles, okay? So we don't want to refer to this, this angle here because it's obtuse. So you want to instead subtract 180. So you don't want to do this for your reference angle. It's 180, or sorry, 225 minus 180. So it's always the angle, the smallest angle that's made with the x-axis, if you want to think of it that way. The reference angle here is always the smallest angle made with the x-axis. So here it's 45 instead of being 135. Okay, it's not 135. Does that make sense? Yeah? Good question. Good question. Again, that's a reference angle question. So, all right. Any other questions about this example here? Okay.